Hello, everyone. It is fantastic to be talking to all of you. In today's session, I'm going to talk to you about what is the power of Snowflake Openflow. So I'm going to present to you a series of slides, and followed by that, I have a short demo as well. Just to introduce myself, I'm Karthik Raman. I am based out of Chennai in India, and I work for LTIMindtree, and I serve as a head of technology for the Snowflake Practice. Also, I am one of the Snowflake data superheroes across the globe. And in addition to that, I am very passionate about contributing to the community. So, as a part of my community activities and involvement, I lead the Snowflake Chennai user group chapter, and I'm also an avid technical blogger. I can be followed on the Medium channel. The link is listed on the screen. And in addition to that, you can follow me on LinkedIn. So today I'll get to the topic. So the topic for today is OpenFlow, one of the cool features that got introduced at the Snowflake Summit earlier this year. What is exactly Snowflake OpenFlow? As you can see on the left side of the screen, um, traditional data ingestion often involves dealing with multitude of data types, structured, semi-structured, unstructured, files, databases, APIs, sensor data, streaming data, all flowing from a variety of data sources. Historically, ingesting these diverse data sources into your analytical data platform has been a complex, time-consuming, and code-intensive endeavor. And not anymore. There comes steps in OpenFlow. OpenFlow is your single-stop ingestion solution for all your ingestion needs. At its core, Snowflake Openflow is a managed integration service built on open source Apache NiFi. Apache Openflow offers a managed experience that significantly simplifies your data ingestion needs. In terms of what does it solve? Number one, it reduces the time and complexity. OpenFlow drastically cut down the time and time it takes to build your data pipelines, especially when your data is coming across hybrid data sources. And it replaces the need for like any extensive custom coding, because it provides you a reusable out of the box components that you can just drag and drop. Basically, you'll be able to accelerate your development cycles when you use OpenFlow. That is number one. Number two, now we are living in a AI era. OpenFlow is able to intelligently process unstructured documents, making them AI ready. With tasks like test, you can do things like text extraction, parsing, chunking, embedding. All that you can use. You can do using OpenFlow. You can process vast amount of documents, and then you can and get insights out of it, and then you can feed it to your large language models. And OpenFlow, the third point is OpenFlow. It streamlines the end-to-end data ingestion cycle from the moment the data enters your system to the time it becomes ready for analysis. OpenFlow streamlines the entire data ingestion process, including data capture and incremental processing, etc. So OpenFlow is your one-stop ingestion tool to take care of all your ingestion needs. What sets OpenFlow apart? As you can see on the right of your screen, there are pre-built connectors that comes out of the box with OpenFlow. So when I say pre-built connectors, what I mean is OpenFlow comes with a rich library of pre-built connectors for common sources, like whether it is your SharePoint or S3 or Google Drive or APIs, FTP, so and many more. So when you're using any of these data sources, there are out-of-the-box pre-built connectors that is available that you can leverage for your integration data ingestion efforts. You literally have a large set of connectors and processors readily available to bring the data from any data sources and make it available on Snowflake. The second point I wanted to highlight is multimodal ingestion. This is where the OpenFlow truly shines. It integrates advanced capabilities like optical character recognition, OCR, or like a natural language processing, NLP, And you can use OpenFlow to intelligently ingest and understand the data of various modalities. This means data, whether it is in SharePoint or Slack or Google Drive or any other source, can be made directly accessible and available within Snowflake. And it is, as I mentioned, it is a low-code visual interface. But since it is built on NiFi, it offers you a very powerful low-code visual interface for building your connectors and then custom processes if you want to create for any of your data ingestion needs. You are empowered to do that. In essence, OpenFlow is not just a ingestion tool. It is a comprehensive solution for modernizing all your data pipelines and preparing your data for the AI driven data needs that you have. Moving on to the architecture of OpenFlow, I wanted to spend a couple of minutes here. As you can see, it has three main components. One is control plane. Control plane is your orchestration layer, sort of, you can say. It is on Snow side. OpenFlow control plane, you can manage the orchestration and scaling of your OpenFlow data pipelines from a familiar multi-tenant control plane, which within Snowflake itself. And the data plane is where you have all your pipeline will be running. And OpenFlow offers a rich flexibility here. The data plane currently, like, it can be deployed in two different ways. One is within your own VPC, the cloud VPC environment. So this is often preferred by the organization which has strict data residency or security requirements, allowing them to maintain full control of the compute environment where the data is processed. In such cases, the BYOC, bring your own cloud option of deploying the data plane on the customer VPC, that needs to be chosen. There is another scenario where customer, like, they want customers, like, they would want a simplified deployment and management, where they can just, like, focus on their data flows rather than worrying about infrastructure. In such cases, we can deploy the data plane on Snowflake Snowpark Container Services, which is the SPCS. So as I mentioned, the two deployment options are, one is the cloud BYOC, deploying the data plane in the cloud hyperscaler VPC. The other one is SPCS. And what you see on the left is the bottom half. OpenFlow offers you a seamless interface for designing, monitoring, and managing your data flows. It is a multi-tenant platform, as I said, responsible for managing and orchestrating your data pipelines and associated runtimes. And OpenFlow, as I mentioned, it offers a wide array of connectors, whether it is your SaaS connectors or database connectors or your streaming connectors, unstructured connectors. There are plenty of connectors which comes out of the box. In addition to that, depending upon your needs, you can create your custom connectors for your data ingestion needs. Moving on, with now that OpenFlow is available to all the Snowflake data teams and data engineers, how does the overall Snowflake for data engineering ecosystem looks like? As you can see, in general, any data engineering process can be broken down into three stages: ingest, transform, and orchestrate. Primarily, for this today's session, I'm going to only focus on the ingest part, where it is OpenFlow. It is your primary mechanism for bringing data from any data sources, whether it is on-prem or like databases or audio video files, whether it is any of the SaaS applications, PDFs, or like streaming data sources. OpenFlow acts as an intelligent gateway, handling the complexities of these diverse data formats and diverse data sources. And once the data is, you are able to bring the data in, you have a variety of transformation and orchestration options natively within Snowflake, whether it is dynamic tables or Snowpark or tasks or DBT projects. You have a multitude of data transformation options for your transformation and orchestration needs. And finally, in the deliver layer, as you can see, you can also use OpenFlow that can be used for delivering the data outside of Snowflake. So what I mean here is, for reverse ETL also, you can use OpenFlow. So using Openflow, you can take the data from any data source and load it into Snowflake. And then from Snowflake, you can take the data and then you can do reverse ETL also back into the source. So Openflow gives you a powerful capability to take care of all your ingestion needs. And at the bottom, you see the automate layer where notebooks, workspace, VS integration, Git integration, all that is natively available on Snowflake. So I will not spend much time here. So for today's session, what we are going to do is primarily we are going to cover two specific use cases. One is the first use case is going to involve structured data processing. So when I say structured data processing, we are going to take the data from a Redshift and then load it into Snowflake. We are going to use a connector called DBCP connection pool. And for the second use case, what I mentioned, what I'm going to cover is unstructured data processing. When I say unstructured data processing, there are images sitting in AWS S3. So we are going to use Openflow to move the image files from S3 into Snowflake internal stage. We are going to use a connector type called AWS Credentials Provider Controller Service. And then once the image files are moved into Snowflake internal stage, we are going to extract insights out of it using AI extract, AI SQL basically, and then we are going to load the extracted information into a table within Snowflake. So this slide talks about the flow of the first use case that I just mentioned. The theme is Redshift to Snowflake migration. So as I mentioned, we are going to extract structured data from AWS Redshift using NiFi DBCP connection pool for efficient GDBC connectivity. And Openflow runtime in Snowflake handles the pipeline execution, scalable, reliable, and fully managed. And data flows via Snowflake internal. We are going to create data flows, which is going to uh, read that data and then load it into final target table. So this is the first flow. The second flow is going to involve, as I mentioned, the theme is unstructured data processing. In terms of art of possibilities, you can do images, PDFs, text, etc., etc. But for today's demo, I'm primarily going to focus on images. You're going to bring a set of images which are sitting in S3. We are going to use a NiFi connector and then and get that image files moved from AWS S3 into Snowflake internal stage, and then we are going to extract insights out of those image files using Cortex AI SQL. Basically, we are going to use AI extract to get insights out of the image files, and then we are going to store that extracted insights into a Snowflake table. So this is how maybe I will, when I get to the demo, I'll show how the Openflow deployment and runtime looks like. And so as I mentioned, generate flow. We have things like we have multiple processors that are available. Generate file flow. It initiates the pipeline trigger. The next processor is execute SQL record. It extracts the data from Redshift. There is a convert record processor that transforms the results into a CSV file. And there is a processor called a put file flow into table stage that loads the data into Snowflake staging. And then there is a processor called a copy into target table, which executes a copy command to load that extracted data from CSV into a target table. And then finally, there is a processor called a merge into fact, which performs a deduplications and does the upsert functions into fact tables. And finally, moving on to the next use case, we are going to use a series of processors. List S3, fetch S3 object, create named stage. So I will explain when we get to the demo. Now that we have looked at a lot of slides, I want to show you something real. So I want to show you how the Openflow interface looks like in real. So I will quickly jump over to the Openflow interface. So if I go here, so once you log into your Snowflake account, this is the home page you're going to see. So what you see on the left is you have a whole set of menus available. From that, if you click on the second menu, which is the ingestion, you need to click on the OpenFlow option that is available. That is again going to take you into this page. So you need to click on Launch OpenFlow, and then here it is going to prompt you to enter your login credentials. So since I've already entered, it's not asking. So once you enter your login credentials, so it is going to take you to this page. So this is where you have the flexibility to create the deployments and runtimes. So deployment is the first step. So once you log into the OpenFlow, you need to create a deployment, especially when it is your first time. You need to go to the deployment tab, click on the create deployment option, and then you need to give a name for your deployment, and then like it is going to ask you to select what is the version of deployment you want to create, whether it is a BYOC version or whether it is a SPCS version. So you need to select all that options and then finish creating the deployments. So once you are done creating the deployments, it is going to show all the deployments that you have created. And once the deployment is created, within the deployment that you just created, you need to create a runtime for you to run your data flows within that. So you need to go to the runtime tabs, and then here you need to click on the create runtime option, and then you need to give a name for your runtime, and also you need to select, okay, what is the name, what is the deployment under which you need to create this runtime. You need to specify all the required details to create that runtime. And once that runtime is created, it is going to show up on this runtime tab on the screen. And once you click on the runtime, so for this purpose of today's demo, I've created the OpenFlow demo runtime. So once I click on that, it is going to take you to this page or this canvas where you need to create your processor groups or your process flows or data flows. So for today's demo, I created two different process flows, processor groups, I would say. One for the first use case, Redshift to Snowflake, and the other one is unstructured data processing into Snowflake. So when I click on the first processor group, this is the process flow or the data flow I have created. As I mentioned, generate flow file, it triggers the whole pipeline execution. And then if you right click on this, configure this in this particular processor, this is where, like, in the properties, you will need to define what is the file size, batch size, what is the format, what is the name of the table that we are loading, what is the database name, what is the schema name, stage name. All these parameters you need to define within the processor generate file flow. And once you specify this, a connection is you need to make a connection to the Redshift database, and then you need to extract the record. So what it does is this: you have a processor called execute SQL record. What it does is it makes a connection to your Redshift database, and then it pulls out the record or the data set based on the queries you have specified. So here, if you go to the configure, within the properties, we have clearly specified what is the uh, SQL that needs to be executed. So here we have already parameterized the table name. So what I've done is I've given the query that will be executed against the Redshift DB, and then the data will be extracted, and then like it will be kept in the memory. So that is what happens on execute SQL record. Once the query is run against the Redshift database, and then the data is extracted and then kept in the memory, the next step would be write that result set into a CSV file. So that is where the parse CSV into NiFi CSV format processor comes into the picture. So here, if you click on the properties, I've already defined all the parameters in terms of scheduling and all. So if you see, we are going to use the CSV reader property and also we are going to use the CSV record set writer property. So what it does is, as I mentioned, it writes all the results and data into a CSV file. Once that file is written, what we want to do is we want to move that CSV file that got created into a Snowflake internal stage. So as a first step to that, we need to create a table stage. So there is a put flow file into table stage. So here, what I have done is I've defined, okay, what is the database, what is this schema, table name, all that is already defined. And we are using the Snowflake connection service property. So what happens here is the flow file, put flow file into table stage. It moves it creates a named internal stage within Snowflake. That's what happens in this particular step. And the next step is copying the files into the target table. So if you can copy files into target table. So here we have clearly given what is the copy into command that needs to be executed to load that CSV file into the target table. So I would define the copy into command here. What is the database schema, table name, all that. What is the file format, compression, all that properties are defined here. So this put copy files into target table processor, what it does is it executes the copy command in the background and it loads the CSV files into the target table. And finally, the last processor is merge into fact. What it does is it reads the intermediate staging table and it executes a merge command to do upserts into the final target table. So it executes a merge into the final table, which is a user demographic fact, and it does an upsert operation into the final target table. So in interest of time, I will quickly show you. These are I'm truncating the final table. I'm also truncating the intermediate table user demographic. So both the tables are currently empty. So once I go to the canvas, so there are two options. I can either run all these processors one by one, step by step. So I can click on each of these processors and then run once. But in the interest of time, what I'm going to do is I'm going to do a start. So right click on the canvas and then click on start. What it is going to do is it is going to execute the whole process flow or the data flow in one shot. So what I'm doing is I'm clicking on start. So see, all the icon like changed from red to green. So it is currently in this step. You see the small icon which indicates that it is currently in this step. So to see whether this whole execution completed, I will click on like refresh, and then so it says success. So what I can go do is I can go to the user demographic fact and then see the data is already loaded into the intermediate table. And finally, when I check the final fact table, so what it does is the data is extracted from Redshift database and then written into a CSV, and then the CSV file is moved into a table in Snowflake internal stage, and then it is loaded into a staging table, and from the staging table it is loaded into the final fact table. So when I click on refresh, so it says it is completed. So what we saw in this first use case demo is we are able to load the data from Redshift into extract the data from Redshift and load it into Snowflake. Quickly moving on to the second use case, I will go back to the main canvas. This is the second processor group I created for the unstructured data flow data to Snowflake. As I mentioned, there are a multitude of processors available. Out of that, list as 3. It is going to list down all the image files that are currently available in the S3 bucket. So what I have done is in this processor, I clearly we are using the AWS credential provider control service. We are making a connection to the AWS S3 bucket. and we are filtering out the specific directory path where the files are available within S3. So for that, we are using the filtering directory path processor. And once we reach the specific directory or the specific location within the S3 bucket, what we want to do is we want to fetch all the files, which are the image files from the S3 bucket. So that is where we are using the fetch S3 object processor. So what we are doing here is, again, we are defining what is the bucket name and all the credentials associated with it. So when this processor, it fetches us all the objects, and here the next step will be to, once the objects are fetched from the S3, we need to create a stage within Snowflake. So we are making use of the processor create a named stage processor. So here we are telling Openflow to create a new stage if it is not already created. So we are specifying a command to create a new stage. We are specifying what is the database and schema under which this particular stage should be created. So once this processor is executed, it will create a named stage within Snowflake. And the next step would be, once the stage is created, we are making use of the put Snowflake internal stage file processor to move all those image files that were fetched from the S3 into the internal stage that was created on the previous step. So here, what we are defining here is, again, we are making use of the Snowflake connection service property. So we are saying, okay, what is the database schema and what is the name of the stage where the files needs to be moved. So this is the name of the stage. And finally, once the files are moved into the stage, what we are going to do is, we don't want to just like read the data and then load it into a file. So we are using, in this particular demo, what I've done is I've made use of the AA extract, AA SQL. So the AA extract command. So what we are doing here is, if you see on the screen, the final table is employee info. That is where we are loading. But before that, what I am doing in this step is, I am using the AA SQL AA extract functionality to get insights out of the image files. We are getting informations like Aadhaar number, which is something like your SSN number, date of birth, address, all this information, name, sex of the a person, all that information we are extracting from the image file using the AA extract functionality. And then we are inserting that extracted information into the employee info table. So this is at a high level, like what we are doing in this particular flow. So quickly moving to the table. So let me truncate this employee info table. So I have truncated the employee info table. So what I've done is, right now the table is empty. So going to the second processor group that we created, as I mentioned, in interest of time, I will not run all these steps one by one. I'm going to run all of them in one shot. So as you can see right now, all these are like in stopped status. So when you click on right click and then start, this flow starts running. So right now it is in this first step. So let me try to refresh. So as you can see on the bottom, the loading has started. So quickly going to the employee info table. So it is having 7 records are loaded. Slowly, like the records are, more records are getting loaded. 10 records are loaded. So I think the loading is like complete now. So what we did is, there are image files that were sitting in S3. We moved that image files into Snowflake internal stage, and from there we use the AI SQL, the AI extract command to extract things like Aadhaar number, which is like SSN, date of birth, address, name, and the sex of the person. All this information we are going to uh, we extracted from the image file using the AI extract command, and we loaded that into Snowflake. So these are the two high-level use cases. The art of possibilities, I would say, are like unlimited. So I would strongly encourage developers and data engineers to go and explore OpenFlow, explore what are all the native connectors that are available out of the box, and then explore all the different processors that are available out of the box and ready to use. I hope you all enjoyed the session today, and hope you go on and leverage OpenFlow to its maximum potential for your day-to-day data ingestion needs. Thank you all.